is Victor Kilowatt 1 Juliet Tango. Victor Kilowatt 1 Juliet Tango.
1, 2, 3, 4. 1, 2, 3, 4. This is Oscar November 6 Romeo Foxtrot. Welcome back to my workbench. In the previous video, you might have seen a Quansheng UV-K5 or UV-K6 such as this one being used as an M17 transceiver. And today, I wanted to go a bit more in depth in this topic, show you why this is useful, what you can do with it, and how to carry out the mod. This feature is often known as a flat audio or 9600 baud connection. It gives you direct access to the FM modulator and demodulator, bypassing any audio filters. That allows you to connect it to modems for high-speed data modes, 4FSK or GFSK, such as digital voice modes that we know of today. So you'll find those flat audio radios with a 9600 baud connector out of the box on multiple models of mobile rigs. So I have here an ICOM IG-E880, which has such a packet connector. Very often they have two pins in there, which are a 1200 baud pin and a 9600 baud. 1200 baud basically means that you're going through the same path as you would with a microphone and speaker, just that it's not adjustable, so it's a fixed level. 9600 baud means you have direct access to the modulator and demodulator, bypassing the AF filters and pre-D emphasis. Here's another example with a Motorola GM360, 340 or CDM something in the United States. Does the same thing provided you enable it in software. So you have this rear connector that gives you direct access to the mod and demod. That's why you'll find a lot of those radios in repeater projects or multimode digital repeaters projects coupled with an MMDVM, because they give you that capability. However, this feature is almost non-existent in handsets. The AF filters are almost always on, which makes it impossible to use them, say, for a compact portable repeater or high-power hotspot. So having this capability on such a ubiquitous and cheap device really opens up a world of possibilities. I cannot go any further without crediting the original author of this mod, Rob Riggs, Whiskey X-Ray 9 Oscar from MobileLink, who first published a quite extensive guide on GitHub 6 months ago on how to perform this mod. I found it to be quite groundbreaking and was surprised that no one communicated on it before, hence why I'm making this video. So what we'll be doing today is see how to perform the mod on the radio. So it requires reflashing the firmware, as well as replacing a couple of components to correct the lower end of the frequency response. Then I'll make a few demos using either an MMDVM, so we'll see how to adjust the levels and how to hook it up, and we'll do the same with an M17 Module 17 modem. Before we begin, I just want to stress that it requires opening up the radio and dealing with quite small size components. I almost wrecked this one by doing the mod. So those are 0805, and some of them are even smaller, or 603 or 402. So make sure you're comfortable working with that size component before starting the hardware mod. Also check out the GitHub page on MobileLink's repository, because you'll find the most up-to-date information. So the links I'm giving you will point back to the most up-to-date guide. So to begin, first we must reflash the radio, and this is quite straightforward nowadays. You just have to press the PTT, turn the radio on, and it shows the LED here. Then you just connect the cable and head on to the flasher website to start. Once your radio is hooked up, you can start the flashing process. Make sure you're using Chrome or Chromium, as this doesn't work under Firefox because it doesn't support web serial. So click on Flash Firmware, specify the port you're connected to. So this is just a cheap AliExpress multi-type programming thingy connected here, and we can just click connect, and then the flashing process will begin. It will be quite fast, and the LED will blink as shown here. So this is a pre-built binary, which is available again on MobileLink's firmware page. But you might want to check it out, because there might be some other updates. So right now we have the newer version, which adds a very important setting here, which is here in the mode part, demodulator. And you just want to go here and change it to digital. So that way you'll have the digital mode enabled, which disables pre-emphasis and de-emphasis and some filters. However, this alone, as I said, might not be enough for your use case. So you might still want to do the hardware mod. So remove the battery, pull out the volume knob here, and then wedge a screwdriver or a blade or something, make sure you don't hurt yourself, between the case and the aluminum shield here. And this will allow you to lift out the chassis like so, and then pull it out slightly. Once that's lifted out, you can start pulling it, and it will just slide out like this. The plastic of the Kenwood style connector will fall off as well. Just put it on the side right now, and then open up the radio as such. You'll then need to desolder those two wires here, and then lift out the display. So the display can be lifted out by pressing on this tab here. Be gentle and don't push it too hard. Just press it slightly, and then this display will just swivel out like so. So once that's done and you took the display out like so, be careful, as a ribbon cable is quite fragile and is not standing on a connector, it's soldered in. So don't pull it too much, otherwise you just might end up ripping it. Unscrew those 5 screws here and unscrew those 2 locking nuts. That will allow you to remove the entire PCB from the chassis and work as well on the backside. Once you've removed those 2 nuts here and the 5 screws, the PCB should be able to lift itself out. It might still get stuck with the pad that helps for heat dissipation between the chassis and the PCB. So now we can just take that out, put that aside, and we have our PCB. So the first part of the mod will work on the audio input filter. Again, refer to the GitHub manual that Rob posted, because it has everything in there. So what you'll have to do is remove C77 and R69 and replace R69 with a 1 microfarad capacitor, as explained here. So this is the picture, and this is the original circuitry. So now that I removed both components, I'll short this one here with a resistor wire, and then put the replacement 1 microfarad cap in this spot. So this part is now done, so as you can see here. And the second one we need to change in the input filter circuitry is here, C31, which is originally 22 nanofarads. And we have to increase the capacitance to lower the cutoff frequency. This is done by putting 2 extra capacitors in parallel. And this one is a bit more tricky because you have, I think it's a 0401 in parallel with 2 0603s. So that might take a bit more time to get right, and I hope I won't rip out any pads. In the previous one, I managed to even remove the original capacitor, so I had to put 4 of them in parallel to get the same capacitance. So that is now our second mod down. As you can see, I sadly had to remove the 0402 component because I wasn't able to solder in parallel with it. Added 2 resistor legs and then just put 4 of those 10 microfarad capacitors to get an equivalent capacitance of about 40 microfarads. Tested good with a multimeter. No shorts anywhere, including this pad, and now we're good to continue on the other side of the PCB. The last mod we need to do on this radio is this very small capacitor here. C71 has to be removed as well and shorted, so replaced by a 0 ohm shunt. Read a piece of resistor wire that I'll try to stick in there. So this is the exact component that needs to be removed. Right. So now the capacitor is now removed. I replaced it with a piece of wire soldered to the 2 pads here, so I checked the continuity as well. The end of the wire is against this resistor here, but as they're connected anyway through a trace on the PCB, it doesn't change much. So this is not going anywhere, and now we're good to reassemble the radio. While reassembling the radio, make sure you put the plastic thingy over the 2 connectors when we're putting it back together, and make sure the buttons are all in the right place, otherwise one might get jammed, such as this one mainly. So, and make sure you've cleaned the display as well. So now everything is ready to be reassembled. Just snap it in place and you should be good to go. So all the buttons are okay, PTT is still fine, and you've got the plastic cover. So now you just have to put the volume button back on. Okay, so now that you've finished this mod and put the radio back together, test it out. So use microphone and speaker. Keeping in mind the audio quality will be perceived as quite bad because you're in digital mode, so you have no pre-emphasis, etc. This one had a bad solder joint on the first mod, so I had to redo it. But as long as you've got audio coming in and out of the microphone and speaker, you're good to go, and the mod has been successful. Now let's see what we can do with either module 17 or an MMDVM. So we'll go through the setup together and see how we can use them in combination with this radio. All right, so now here's one demonstration while using module 17. So you have this cable that I made using an AliExpress cable you can buy with just the wires here. Cost about 4 to 5 euros in AliExpress and connected straight to the Kenwood style connector. And then, well, I'm hooking it up to the ground, PTT, RX, and TX baseband audio. On the radio, here I'm using VHF, but you can do it on UHF as well. I'm changing a few settings. So first of all, squelch, which I'm lowering down to the lowest position. TX power will be working low, doesn't need much more right now. DCS, TCSS has to be disabled. Offset, we're working simplex. Wide for now. You might at some point change that for other modes. We'll see with the MMDVM. Scrambler off, compounder, etc. Demodulation needs to be on digital as well. So once that's done, you need to adjust module 17. So you have two versions of this one. This one has either what we call soft pots, which means you can adjust the values of the modulator directly in the menu here. Within module 17, you can adjust the TX and RX soft pots, or you'll have, like I have here, physical adjustments for RX and TX. So that means that you need to change the peak-to-peak voltage of the signal that goes from module 17 into the radio. And this will change the deviation of your signal and the space between each 4 FSK transition. To measure it in TX, my best advice would be to go with an SDR with SDR++ and the M17 plugin. So right now there's nothing here. Let's use a known good working radio. So my ICOM radio here, modified with module 17. So this one has been calibrated and shows the right transitions. So if you use one, directly shows the call sign and the transitions themselves. So you really want to have those 4 lines aligned with the reference here. So we need to do the same thing on this rig. So you'll have to adjust it. So this is a bit too low, so you want to increase the modulation to have it evenly spaced out. Hard to do it with one hand, so let me adjust it and I'll get right back to you. So now the deviation is adjusted as good as I can get it, but I'm still not getting any decodes. So that might be because your phase is not correctly set up. So you need to go into the menu again. So menu, settings, module 17, and go into TX phase and put it, well, change the setting from normal to inverted or inverted to normal, and see if that helps solve the issue. And yeah, I have my voice coming through. 1, 2, 3, ON 6 Romeo Foxtrot testing. And you see the other radio is decoding as well. So now that's for TX. For RX, you need to adjust the audio coming from the radio into module 17. So first, make sure your audio volume, because this will change, the level will change according to volume. So I'd suggest you put it about 1/3 of the way, so you're not saturating anything on the radios or on the filters here. And then what you want to do is you need another rig, so either whatever other M17 setup you have, or an MD380, for instance, to generate a reference signal and adjust the RX so that you're at the maximum of the range of the converter on the microcontroller. So that would be 3.3 volts peak to peak. So you can do that either with an oscilloscope, but there's an easier way using a multimeter with AC voltage. Be careful because you'll be measuring RMS voltage, so make sure you adjust accordingly. So that would be about 1 volt RMS. So yeah, if you check onto the M17 Foundation's wiki, The M7 Module 17 Quick Start will give you the procedure I'm giving here. You can use a digital multimeter, and you should have about 1.1 volts RMS at the test point, which is called RX post. So you put one probe onto any ground pin you can find, and then you put the other probe on this test point, start transmitting, adjust it to 1.1 volts maximum. So that will give you maximum range, so you'll have the maximum dynamic range for your Module 17. So let's just go back here, and you should have the call sign being decoded. Oh, and 6 RF testing. So now, quick word of caution with those cables, they're not shielded. So if you're using an antenna, and I've seen that sometimes RF will just go back into the cable and mess up your audio. That's why I'm using a dummy load here. So either use an external antenna or build a shielded cable to make sure you don't get any interference. I had the same issue in here, and I used ferrite to limit that, and now that's under control. Your mileage may vary in real-world performance. This is all very new, so I'd be really interested to see if anyone else tries it and see how well it performs over a repeater or on longer ranges. So yeah, this is still highly experimental. Let's switch to the MMDVM now. So the hookup procedure is very close as the M17 or Module 17. So you need a repeater board, or this one is made by BI7 JTA. Shout out to him for having this one available. You can have it for about $70 right now. It sends audio through the AF input and output, provided it is still unfiltered, which is exactly what we did here. So you have to do the same thing and hook up PTT, RX, TX, and ground. So I did first test with jumper wires on this connector, which is the one I built for Module 17. But in the meantime, I rebuilt something a bit cleaner that allows me to get a straight connection to the radio. So to adjust the audio levels on the MMDVM, you must use those two multi-turn potentiometers. So one of them is going to act on the transmission part, TX, and the other one on reception. We'll focus on TX first. You could either use a test set, if you have one, to adjust the deviation by putting the MMDVM in calibration mode, or you can use NSDR, as I'll be demonstrating here. So you have to put the MMDVM in calibration mode. This really depends on the software you're running. I'm using WPSD here, so the command is, well, sudo space WPSD modem calibrate. Press enter, and this will put the modem in calibration mode. Then you have a slew of different options for deviation tests and tests palette tones, but we're going to use DMR deviation mode. So just press uppercase D and then press space to initiate transmission. And the idea here is to adjust the TX level until you reach a 0 on the carrier. This is called a Bessel zero method. You need to go to the TX potentiometer and adjust for a minimum on the carrier. Increase or decrease the level of the modulation. Carrier lowering. So if you're going too far, it's going to go back up again. So you really need to have it as low as you can get it. Now you have 2.75 kilohertz of deviation. You can press space again, and that stops the transmission. Now your TX deviation is correctly set up. So to adjust the RX levels, ideally, you would want to measure the voltage coming into before the STM32's analog to digital converter and adjust for maximum peak-to-peak value or RMS if you only have a multimeter. However, I don't see a test point, or I don't know about it. So what I usually do is generate a signal using, for instance, a digital radio. You can either do that in DMR, NXDN, D-Star, whatever. And I adjust the RX level for minimum BER. So to do that, you go here. So we're doing NXDN, but again, do that in DMR if you want. So for NXDN, I'm going to do BER test mode for NXDN, so I'm pressing lowercase n. If you're doing it for DMR simplex, you have to press lowercase b. So let's go into NXDN test mode here. And what I'm going to do is just start transmitting with my radio and see the BER here. So right now it's not decoding much, to be honest. Or the BR is quite high. So what you want to do is adjust RX one way or another and see how the BR changes. Yeah, there we go. So this is already less than 3 errors, but you can probably do even better. So now that you have got all those levels adjusted, it should work on any digimode you throw at it, except POXAG, as it requires first a frequency change to 439.98750, depending on where you live, and the deviation needs to be 4.5 kilohertz, and I cannot reach this level of deviation with this setup. Regarding performance, it works really well on NXDN, so I've had some really good reports both in RX and in TX. BER is almost down to 0. In DMR, I'm still experiencing some issues, and BER is still around 1%, which is still way too high to my taste. And I believe this is linked to how DMR works and the fact that it receives TDMA, so short bursts, and that the receiver sometimes behaves somehow weirdly with this kind of frame. So I'm still seeing how I can reduce the BER even lower, mess with the settings, and see if there's anything else I could do to improve receiver performance. That being said, what I want to try later is add a second Quansheng radio, put a duplexer, and use it as a full-fledged repeater, integrate all of that into a nice case. Anyway, that's it for today. I hope this was of interest to you. Perhaps you have other ideas that could be applied to this kind of mod. I'd be really interested to see what you come up with, so please let me know. Send it over, for instance, to the M17 or WPSD Discord. Keep in mind, this is still a Quansheng radio, so it will never perform as good as, for instance, a mobile transceiver. In terms of flat audio or RF performance, generally speaking, either the receiver or the transmitter, harmonic content might still be problematic in some jurisdictions, even though this is still way better than a Baofeng. So that's it for today. Thank you very much for watching, and I'll catch you later.